Okay, now we're ready to start section 5 of chapter 9, where we're going to be hypothesizing about the population proportion. So I'm going to do problem number 37, problem 37 on page 386. It said a study found that in 2005, 12.5% of U.S. workers belonged to unions. Suppose a sample of 400 workers was collected to determine whether or not union efforts to organize have increased union membership. So it says, formulate a hypothesis that can be used to determine whether union membership has increased since 2006. So again, we're going to ask ourselves, what are we trying to prove? And we're trying to prove that union membership has increased. And so we're trying to prove that the population proportion is now greater than what it was, which was 12.5%. So for part A, to write our null and our alternative hypothesis, this does not contain an equal sign, so therefore we can't make it our null, but so we'll make it our alternative. So our alternative is that the population proportion is greater than 12.5%. So our null would have to be that the population proportion is less than or equal to 12.5%. So our curve would look like this. It's a one-tailed test. Less than or equal to is over here. So this is our little rejection region over here. Okay, so that's part A. Part B then says if a sample shows that 52, so we sampled 400 workers, told us back in the beginning, and said the sample showed that 52 of the workers belong to a union. What is the p-value? So in order to calculate that and do the test statistic, we have to find the sample proportion. So 52 out of the 400, which is 13%, is our sample proportion. Now we're ready to plug it into our formula for the test statistic. And when you're hypothesizing about proportions, you always use a z. And the formula for that is sample proportion minus population proportion divided by the square root of the population proportion times 1 minus the population proportion divided by the sample size. And that formula is on page 382. Okay, so when we plug in our numbers, 0.13 minus 0.125 divided by the square root of 0.125 times 1 minus 0.125 divided by the sample size of 400. When you do the math on that, you get a z-value of 0.3. Okay, so now we need to turn that into a p-value, so I'm going to do that on the next video.